Hey, what's up, guys? This is Dr. Vivek Palipuram bringing you the next lecturette in ECPE 127. In this lecturette, we are going to solve some problems pertaining to joint probability density function. So let's start with problem number 1, where you need to first find the value of the constant C and then find the marginal PDFs. What I would like for you guys to do is focus on finding the constant value C and the marginal PDFs of X and Y. You can pause your video here. Once you're done, you can unpause and I can show you the solution. Okay, so let's look into finding the value of the constant C. So f of x comma y is given to us as c times e to the negative 2x plus 3y for x greater than or equal to 0 and y greater than or equal to 0, and it is 0 otherwise. So this region right here is the region of non-zero probability. It will be useful for me to first plot this region of non-zero probability and keep it ready. So let me use a black pen for this. This region right here is the region x is greater than or equal to 0 and y is greater than or equal to 0. Because both x and y are positive, it means that we are looking at the first quadrant. To find the value of constant C, I'm going to use this fact that by double integrating the joint PDF or the region of non-zero probability should give me value equal to 1. So I will double integrate this joint PDF over this region. Now I need to find the limits of integrations. So first I need to find the limits for the inner integral with respect to y. So here's how I can do it. For any value of x, y varies from 0 all the way to infinity. So that's the limit of inner integral from 0 to infinity. Similarly, for integration with respect to x, for any value of y, x varies from 0 all the way to infinity in this region. So the limits of the outer integral will also be from 0 to infinity. This gives you a value equal to 1. So let's solve this integral. So when I first evaluate with respect to y, I get 0 to infinity c over 3 times e to the negative 2x dx. It's equal to 1. And next, when I integrate with respect to with respect to x, I get c over 6 is equal to 1, which gives me value c is equal to 6. So I perform the evaluation of integrals inside out one by one. So first focus on inner integral, evaluate it. The other variable is going to be constant when you perform the inner integration. So when I perform an integral with respect to y, x is considered as a constant. So that gives me value 6. Next, let's focus on finding the marginal PDFs of x and y. So marginal PDF of x is obtained by integrating the joint PDF from negative infinity to infinity with respect to y. In this case, y in this region varies from 0 to infinity. So my limits of integration will be from 0 to infinity, 6 times e to the negative 2x times e to the negative 3y. I can write e to the negative 2x plus 3y as a product of two exponents with respect to y. Now because I am integrating y out, this y term will disappear from the region of non-zero probability. So whatever equation I'll get now will be the marginal PDF of x for this region. So when I solve this, I get 2 times e to the negative 2x for x greater than or equal to 0. For other regions, for other values of x, it's going to be 0. So that's the marginal PDF of x. That's the marginal PDF of x, f of x. So let me make a note of the marginal PDF of x somewhere here so that I can compare it with the marginal PDF of y to find it whether or not the random variables x and y are independent of each other. So f of x is equal to 2 times e to the negative 2x. For x greater than or equal to 0, it is 0 otherwise. My apologies for the background noise. That's our rice cooking in our rice cooker. And in addition to that, my toddler is also yelling around alongside the rice cooker. So my apologies for that. Okay, now let's focus on the evaluation of the marginal PDF of y. So let me erase this portion. I know that c is equal to 6, so f of y is obtained typically by integrating the joint PDF with respect to x, but in this case the limits will be from 0 to infinity because x varies from 0 till infinity. 6 times e to the negative 3y times e to the negative 2x dx. So e to the negative 3y and 6 are going to be constant with respect to dx, so they can safely come outside. And I need to evaluate this integral now. When I evaluate this integral, I get f of y as 3 times e to the negative 3y. Now carefully notice here that my region of non-zero probability was x is greater than or equal to 0 and y is greater than or equal to 0. When I integrate x out in order to obtain the marginal PDF of y, I eliminate x is greater than or equal to 0. And therefore f of y is going to be the marginal PDF of y, which is equal to 3 times e to the negative 3y for y is greater than or equal to 0. And it is going to be equal to 0 otherwise. So that's the marginal PDF of y. Now the question also asks you whether or not x and y are independent of each other. X and y will be independent of each other if fx is times fy gives you fxy. The joint PDF. This is my fy here. This is my f of x. So when I multiply them, I indeed get 6 times e to the negative 2x plus 3y. The regions will combine, giving me x is greater than or equal to 0 and y is greater than or equal to 0, which is indeed my joint PDF, and therefore the x and y are indeed independent. X and y are indeed independent. So you can pause your video here to review some of these steps. Next, when you unpause, I'll show you how to solve for probabilities of different regions. So from the previous problem, I identified the value of constant c, which is equal to 6 times e to the negative 2x plus 3y for x greater than or equal to 0 and y greater than or equal to 0 and 0 otherwise. First, I need to find the probability of x is greater than y, and I'm going to show you those 3 steps, how to use those 3 steps in order to find this probability for this region A, which is x is greater than y. So step number one is to draw the region of non-zero probability, NZ. X is greater than 0 and y is greater than 0 is the region of non-zero probability, because for this region the PDF is non-zero, otherwise the PDF is 0. Since both x and y are greater than or equal to 0, I'm looking at the very first quadrant, like this. So that's my step 1, where I draw the region of non-zero probability. Step 2 will be to plot region A. In this case, that region is x is greater than y. Whenever you have to plot such inequalities, it's always advisable to plot the equality relationship first. So let me draw the equality relationship, which is x is equal to y. And then we'll find out whether or where x is greater than y actually is. Okay, so let me draw the equality relationship here. X is equal to y will be this straight line, like that. X is equal to y. Now, the region either above this line or below this line is going to correspond to x is greater than y. In order to find that, there are numerous methods, but I tend to use a very simple empirical method, which goes something like this. I'll randomly select a point on the x-axis. Let's say a far away point here. Now this point, let's say, is 10, 0, where x is 10 and y is 0. So this point indeed satisfies this relationship that x is greater than y. So this point should definitely belong to this region. Similarly, I can consider another point on the y-axis, and let's call it 0, 10. This point does not satisfy the condition that x is greater than y. And therefore, this shaded area is region A. In the same step, I also need to find the intersection between NZ and region A. The intersection region here in this case will be that region where you see both the blue lines as well as the black lines, which happen to be this one right here. So that's the region of intersection between A and NZ. So that region, that triangle, is going to give me the limits of integration. So I'll show you how to do step 3 next. And before I do that, I'll just eliminate a little bit of these extra drawings so that everything looks neat. Okay. In step 3, I need to double integrate the joint PDF from or this intersection region, NZ intersection A. Now the most crucial aspect here will be to correctly identify the limits of integration. So first I'm going to integrate with respect to y and carefully observe how I'm getting the limits of integration. I need to first get the limits of integration for y, and here's how I'll get it. For any x, y varies from 0 all the way to this point right here in this region, which is y equal to x. Now remember guys, we are integrating over the region of intersection, so I'll not exceed this intersection. So in this region, y is moving from 0 to x. So that's the limit of inner integral from 0 to x. Once I integrate y out, x varies from 0 in this region all the way to infinity. So the limits of the outer integration, so the limits of integration with respect to x will be from 0 till infinity. And I need to solve this integral carefully now. So let's solve it carefully. So 0 to infinity, 6 times e to the negative 2x is a constant with respect to dy. So I will have 0 to x integral e to the negative 3y dy dx. So I'm going to focus here. This gives me 0 to infinity 6 times e to the negative 2x negative e to the negative 3y over 3, and the limits are from 0 to x dx. Now that gives me 0 to infinity. 3 and 6 can simplify to a 2, so 2 times e to the negative 2x. And when I plug in the limits, when I plug in an x, I get negative e to the negative x. When I plug in a 0, I get negative 1. Negative and negative give me a positive 1. So let me just work here in order to save some space. So I get 1 minus e to the negative 3x. Okay, 2 is a constant, so it can come out. And what I'll do is I'll distribute the e to the negative 2x terms. So 0 to infinity, e to the negative 2x dx minus integral 0 to infinity e to the negative 5x dx. All right, now I have, for the inner integral, let me just directly write this answer here. So for the inner integral, I'll get 1/2. For the next integral, I get 1/5. And when I solve this, I get 2 times 3 over 10, giving me 3/5 as the probability that x and y are inside of this region. So that's how you solve probability problems with those 3 steps. So this is part A, probability that x is greater than y. Now let's solve the probability that x plus y is less than or equal to 1. That's the next thing that I want to find. X plus y is less than or equal to 1. So let me erase this portion here, and maybe I'll write a little bit smaller so that I do not exceed the space. Okay. So that's my region A. That's my region A. This probability term has to change now. So I need to find now part B, probability that x plus y is less than or equal to 1. So now this is my region A. X plus y is less than or equal to 1. To find this region, let's focus on plotting the equality relationship first. So we'll plot the equality relationship, which is x plus y is equal to 1. X plus y equal to 1 is going to be a straight line. So we can find out let's find out where that straight line is, or how that straight line looks. When I consider x plus y is equal to 1, when x is equal to 0, y is equal to 1. So there's going to be a point right here, 0, 1, which is going to belong to the straight line. And then when y is 0, and in that case, x is 1. So 0, 1 is also going to be in the straight line. So when I join these two lines, I get x plus y is equal to 1. Next, I need to find whether the region above this line belongs to x plus y is less than or equal to 1, or the one below. If I were to consider the origin 0, 0, it clearly satisfies this condition that x plus y is less than or equal to 1. So this intersection region right here is your NZ intersect with A. So I did not show you a lot of steps here. I did not explicitly plot the entire region A because it is not necessary. You can see that from the previous example. I just focused on finding the intersection between NZ and A. So this is the intersection between the region NZ and A. Next, I need to plot over this region, or rather I need to integrate over this region. I need to integrate over this region. So let's integrate over this region. I'll integrate the joint PDF e to the negative 2x times e to the negative 3y dy dx, and carefully observe how I will obtain the limits of integration. For any value x, y varies from 0 all the way to this point right here, which is on this line 1 minus x. Because this line right here is x plus y is equal to 1. So naturally y will be equal to 1 minus x on this line. So this line is x plus y is equal to 1. So any point on this line for any x will be y is equal to 1 minus x. So those are the limits of integration for y from 0 till 1 minus x. Once I integrate y out, x varies from 0 till x is equal to 1 in this region. That's how x varies in this region once you integrate y out. X never goes less than 0, neither does it exceed 1 in this region. So the limits for x are 0 to 1 after you integrate y out, because x varies from 0 to 1 in this region. Now I need to carefully evaluate this integral. Now remember guys, if you get until this step, you would have gotten 90% of your credits. The remaining 10% is to carefully evaluate the integrals. So let's evaluate the integral carefully. So first I'm going to focus on inner integral. 6 times e to the negative 2x is a constant with respect to y. So I'll focus on this integration first. When I do that, I get negative e to the negative 3y over 3. You know what? Let me remove this 3 and change that 6 to a 2, because 3 and 6 can simplify to 2 here. E to the negative 3y, 0 to 1 minus x dx. This gives me 0 to 1, 2 times e to the negative 2x. When I plug in x minus 1, I get negative e to the negative 3, 1 minus x. When I plug in a 0, I get a negative 1. So 0 to 1, 2 times e to the negative 2x, 1 minus e to the negative 3 plus 3x dx. When I evaluate this integral, 0 to 1, 2 times e to the negative 2x dx minus e to the negative 3 is a constant term, so that will come out e to the x dx. When I evaluate the first integral, I get negative e to the negative 2x, limits are 0 to 1. when I evaluate the second integral here, I get e to the x, the limits are from 0 to 1. I get, for the first part, I get 1 minus e to the negative 2. For the next part, I get e minus 1. So that gives me 1 minus e to the negative 2 minus e to the negative 2 again, plus e to the negative 3, which is 1 minus 2 times e to the negative 2 plus e to the negative 3. So that's the probability that x belongs to this interval. And you know what? Let me just verify that this indeed is a valid probability value. I hope I did not make any mistakes in my evaluation. So e to the negative 2 e to the negative 2 is 0.13 times 2. So 1 minus answer, which is that 0.7 plus e to the negative 3. Okay, 0.77, or I'm getting 0.78. So, whew, it is indeed a valid probability answer. For a second, I was scared that this value may be greater than 1, which can never happen. Okay, so that was quite a beefy problem number 1. So again, I'll stop my lecturette right here, which shows you how to solve this problem involving simple limits. Because if you carefully observe here, most of our limits were from zero to infinity in order to find the constant values and to find the marginal PDFs. The limits were a little bit tricky when we were trying to find the probabilities of these regions. So I'll end this lecturette right here, and I'll leave it for you to review this lecturette. In my next lecturette, I'm going to show you a little bit more challenging problem where x and y have some relationship in the region of non-zero probability. X plus y is less than or equal to 1. Such a relationship did not exist in this region of non-zero probability, and therefore x and y were also independent, because there did not exist any explicit relationship between x and y in this region of non-zero probability. But there is a relationship between x and y in this region of non-zero probability. So I think you can guess the answer for this part. All right, I think it's a good time to stop this lecture right here.